Hello. In this video, we're going to start talking about how to solve radical equations. Now, a radical equation is any equation that involves a radical symbol. Now, this is called a radical. Anything underneath the radical is called the radicand. And every radical has what we call an index. Now, for square roots, that understood index is 2. If we have the cube root, you have to write the 3. So the 2 for the square roots, that's just, it's an understood. But for the 3 for the cube roots, that is required. Or if we did 4th roots and 5th roots and so on and so forth. So, here are the steps for solving radical equations. The first step is to get a radical by itself on one side of the equation. The second step is to take both sides to the power of the index. And remember, the index is usually going to be 2 for us. Every now and then you're going to see a 3. I don't think you'll ever see 4 or anything above that. And at that point you will solve. But what's very important here is that you have to check your solutions. If you don't check your solutions, you may not have the actual solution to the original equation. This is the most important step here. The reason why is because the theorem that we're using is the following. Every solution to p equals q is also a solution to p to the n equals q to the n. And here's how you know that. Let me just say x equals -1. Okay, if x equals -1, notice that right here, this is just p and this is just q. So in this case, p is x, q is -1. Notice that if I square that, that means that p squared is going to be x squared. And if I square the -1, it means q squared will be -1 squared, which is +1. In other words, it's going to create the equation that x squared equals 1. That's because I am squaring both sides here. But the solution to this equation, x squared equals -1, is the solution plus or minus 1. In other words, -1 or +1. But notice that this +1 is not a solution. Because if I plug in 1 here, I get 1 equals -1. That means I have to check that to realize that that actually introduced a new solution to the resulting equation that is not a solution to the original. That's going to happen quite a bit for us. Okay, so this is the reason why this fourth step is crucial and is not optional. For many other equations that we're solving, this actually is an optional step. You just have to, trust yourself that you did everything correctly. But with this one, unfortunately, it is no longer optional. It is required. All right. Well, I believe that is going to be it for this video. In the next video, I'm going to start showing you how to actually solve these equations. I'll see you there. Have fun.